evening, friends. After the lectures, after my previous lecture, it's my privilege to be here back again to talk to you about something about the technique of Phaco itself. Hope the previous lecture was useful to you, and if you have any questions, you can always come up with your questions in my WhatsApp number, which will be available to you at the end of this presentation. Today we are going to talk about uh, something about the technique. So let me start with the incision. So when we are doing a phaco surgery, it's different from what you have been doing for SICS. The incisions can be of three types. It can be a scleral flap incision, which is almost becoming obsolete. It's like what you do with for SICS. It's a 3 mm incision from the sclera with a tunnel and then going into the antechamber. Or a limbal incision, which is a very preferred incision because the healing is good. You cut some of the blood vessels, so there is some amount of oozing, and this oozing helps in better healing, and the patients are much more comfortable in the post-operative period. Third is the clear corneal incision. Clear corneal incision is an incision that I normally do in patients who are on blood thinners, anticoagulants, aspirin, so that there is no bleeding or ooze from the incision. Nowadays, for phaco surgery, we do not stop anticoagulants before the surgery because that might have some effect on the cardiovascular system. So I'll tell you the basic techniques of a wound. So first of all, I'd like you to see that what is an ideal wound. As you can see, an ideal wound should have three steps. The first step, which should go almost parallel or almost perpendicular to the sclera, about 1/3 of the sclera. Then it should go parallel to the sclera, and ultimately it should reach the cornea and go into the corneal layers for about 1.5 millimeters inside, and then enter the anterior chamber to form a lip. This lip is very important. Why is the lip important? Because it is the lip which closes the incision. As you can see in this particular slide, that when intraocular pressure rises, the lip is closed, and that's how the tunnel incision becomes self-sealing. If this lip is not there, then the wound will not close in the post-operative period, and you will have leak, and the fluid will come through it, and the wound will always leak in the post-operative period. So that's not an ideal incision. An ideal incision is an incision which will have to have a corneal lip which acts as a valve. So I'll show you a short video. As you can see, this is how we construct the incision. An ideal incision should be constructed with the initial incision, which is perpendicular to the sclera, followed by an incision which is parallel to the iris plane, which should be about 1.5 to 2 millimeters, and then it should enter into the anterior chamber through the cornea with a lip. More, it will cause overlocking of the wound during the surgery. If it's less, it will tend to leak. Now, this is a representation of how you do a scleral incision. We do not do scleral incision nowadays. That is how you cut the conjunctiva. You make a groove in the sclera like you do in SICS, and then you ultimately enter the anterior chamber. What is important is you should go into the cornea for about 1.5 millimeter inside, and then before you enter into the anterior chamber, your tip should be slightly well down position so that there will be a formation of star on the cornea. And if you can get to see this particular star before entering, you know that you have produced a corneal lip. Now, under corneal incision, what you actually do is do the same thing. You make an initial perpendicular to the cornea incision, then an incision which is parallel to the iris, and then ultimately you enter the eye with a corneal flap. So incision in phaco is very important. It should depend on the size of your phaco tip, size of your sleeve, and if you are intending to a 2.2 millimeter incision, you should never use a blade which is 2.8 or 3.2. You should always use a blade or a keratome which is exactly 2.2. And if you are doing making an incision of 2.8 millimeter, many a times when you start doing phaco, you use 2.8 millimeters. And while doing 2.8 millimeter incision, you make sure that you are using a keratome which is 2.8 millimeter only from a reliable vendor, because 2.8 millimeter from a vendor which is not reliable can give you a keratome size which may be slightly high, slightly low, which make your life difficult as you negotiate the phaco tip and as you do the procedure. Either the wound will become fluctuate too much because of leakage of the wounds, or the phaco tip will not go in easily and you will have difficulty. To make sure that you buy the keratome from a reliable vendor, and you should always make sure that you use a new keratome for all of your initial cases, for at least first 10-15 cases. Now coming to the capsulorhexis, what you need to understand in orhexis, this is a very important slide, I must say. What you need to know and understand in orhexis is that your central 6 to 7 millimeter zone, depending on the dioptric power of the eye, in a very high hypermetropes, the diameter of the lens is slightly less and you get a 6 millimeter zone at the center. In a high myope, where the diameter of the lens is high, you get a 7 millimeter zone at the center, which is zonal free. And you'll have to assure that your rhexis is in this zonal free area and it's not encroaching into the zonular area, because that will invariably lead to a runaway rhexis. So a safe rhexis should start at the center. While doing a rhexis, you must assure that the anterior surface of the lens is flat. You have enough viscoelastic to press to maintain a positive pressure within the anterior chamber. You should aim at 4.5 to 5 millimeter rhexis. 5.5 is too on a larger side. You should tear by shearing force, I'll show you, and there should be an overlapping of the ends so that you end outside in, so that there is no irregular edge at the terminal point. If there is an irregular edge, then while hydrodissection or during the phaco, there is a possibility of runaway rhexis. So while doing a rhexis, if you do not maintain a positive pressure, as you can see, these yellow arrows show that there will be a centrifugal force which can, and you get a runaway rhexis. Always you assure that the pressure within the anterior chamber is higher than the intraocular pressure, so that lens is kept very flat throughout the rhexis, and if required, you refill the anterior chamber with viscoelastic so that it remains flat. Few words about runaway rhexis. As you are doing the rhexis, as you can see here, many times you will see that the rhexis tends to run away, and the moment you see that it's running away, you should hold at this position, the black point, and pull it towards the center of the rhexis in order to retrieve it back, and continue with the rexis. There might be a slight at this point, there might be slight distortion of the rexis at this point, but it does not matter much. What you need to do is you'll have to retrieve it back into its in the line of the rexis so that you have a round rexis, circular rexis at the end of the procedure. So while doing a rexis, as I was saying, that you should not tear by stitching. So that is how, if you do a lateral force like this and it cuts in this direction, it's called stretching. You do not really have a good control if you are stretching. Always try to fold the rexis margin over itself and do the rexis by shearing. This you can easily do by injecting viscoelastic on this portion, and the moment you inject viscoelastic somewhere here on the cut portion of the rexis, it will fold on itself and it will help you in completing the rexis in a much more controlled way. Now, as you can see, I'll show you this is how I do a rexis. I make a central nick. After doing the nick, I inject viscoelastic to refill the viscoelastic which has been lost during the entry of the needle. Then I hold the rexis flap as close as possible, tear it for 15 degrees, then I again hold it as close to the cut margin as possible. As you can see, I am holding it as close to the cut margin as possible, and then ultimately completing the rexis outside in. That is how you should ideally do your rexis. I'll show you another rexis technique. While doing rexis, is very important that you should fixate the eyeball with an iris spatula on the other hand. This is how you start the rexis. Hold it as close to the point of tear as possible and do not tear more than 15 degrees at a stretch, and while you end the rexis, make sure you are ending it outside in. Now coming to hydrodissection, that is again a very important step. It's important for SICS as well as it's important for Phaco. It will make your life extremely easy if you have done a very good hydrodissection. Hydrodissection is nothing but injecting fluid between the cortex and the nucleus and the lens capsule so as to create a cleavage line between these two, and move the posterior capsule away from the nucleus as you do the subsequent procedure. Hydrodelineation is injecting fluid between the nucleus and epinucleus so that there is a cleavage line between them. This will help you in delineating the nucleus and doing the phaco with the epinuclear cushion all around. This cushion protects the posterior capsule and protects the other structures from getting damaged during the course of the procedure. So for phaco, you'll have to do both hydrodissection as well as hydrodelineation. Now, if you see the next slide, the basic procedure is you should use both the ports. If you're doing 2 ports and 3 ports, use all the ports to do hydrodissection from all direction. And the number one shows that how you should start hydrodissection. The idea is for your hydrodissection, you should choose the right plane between the cortex and the capsule, and just by elevating the capsular margin a bit, you can go to the right plane and inject very small amount, 0.1 ml of fluid at a time. Do not inject too much of fluid at a time. If you inject too much of fluid, the cortical matter will get disrupted. You will have difficulty in visualization of what you are doing for the next steps. So use very small amount of fluid, just make a small gap, then go to the side 2, inject further amount of fluid, and then from the side port you will go to the side 3. If you are comfortable from the main incision, that's again fine. Then again, this is a small video. As you can see, very small amount of fluid is being injected from all the sides so that we get a very good 360-degree separation between the capsule and the nucleus all around, and the wave of fluid should go also behind. And as you have done it completely, as you can see, you'll be able to see the edge at the edge of the nucleus all around. And after having done that, you need to do a bit of rotation of the nucleus so that the nucleus is freed. Also, the cortex capsule matters are freed from the capsule. After you have done a very good hydrodelineation, after having done the hydrodissection, you should be able to see this golden ring. This is called the golden ring reflex. And if you can see it, you know that you have done a 360-degree and a good hydrodelineation. And the endpoints is a good golden ring reflex, slight shallowing of the anterior chamber, and the nucleus you should be able to rotate the nucleus freely. And the complications of hydro procedures, you must know, if you inject too much of fluid very quickly, irrigation cannula, I use 27 or 30 gauge cannula for hydrodissection. If you use cannulas which are thicker than that, there is a chance of capsulorhexis running away at certain weak points. There can be a rupture of the posterior capsule by the wave if it's weak, or there is sudden prolapse of the whole nucleus out of the bag into the anterior chamber. We do not want any of this, so inject very small amount of fluid at a point and inject very gently. Phaco is a surgery where should be gentle at all steps. Now we come to the Phaco technique. Now we know that there are basically four techniques. One is the trench, divide, or conquer method, which is basically a four-quadrant method. Then there is a stop and chop method. There is a Phaco chop method, and then there is a supercapsular Phaco method. Now, first of all, the oldest and the most nowadays not used commonly, that was the technique that we started doing Phaco with. We divide the nucleus into four quadrants. We make a cruciate incision, one like this and one like that. Then divide the nucleus into four quadrants and then use Phaco power to remove one after another. I'll show a few of my slides. These are the slides which was taken in 2004. That is how we do a divide and conquer method. As you can see that we are making a central deep trench and using a blunt chopper in the left hand and a Kelman tape 2.8 millimeter in the right hand. After I made a deep enough groove, I've rotated the nucleus and completing that cruciate incision in the at 90 degrees to the initial incision. That is also deep enough. How to know it's deep enough? You start seeing the glow from below. The reddish glow can be seen from the center of the tense part of the nucleus. Now, as you do this four trenches, now you can see that I am cracking the nucleus here. This is the first crack which has gone beyond the center and it was completed to the other side. Then I rotate the nucleus, do the next crack. This was not very accurately done. The crack has taken place away from the tensed portion. So I'll make another crack so that I get equal sized pieces. Now I have made it at the tensed portion of the nuclear fragment. Then I'll rotate it again, then crack it again. As you can see, I'll show you how you are going deep inside the groove. with the Phaco tip on one side and the chopper, blunt chopper on the other side. And then I'm removing the nuclear fragments one after another using nuclear quadrant removal settings. Settings itself is a different story. We need to have a separate class on how to set the settings for Phaco emulsification. So I'll go to stop and chop now. In the stop and chop, you make a deep central groove, and instead of making a cruciate incision, you make a straight incision and then crack the fragment into two parts, and then with the help of chopper, we remove the nuclear quadrants one after another. This is again a very old video. After you have done a good dissection, rotated, I make sure that all my nucleus rotates very well before I start doing my phacoemulsification. After making the central groove, I'll do crack the nucleus into two parts, and after the nucleus is cracked into two parts, I'll ultimately remove, break the quadrant into many small parts and remove them one after another. So this is called stop and chop, means initial sculpting to make a deep groove inside, crack the nucleus into two parts, and then finally remove the fragments. Now, a few words I'd like to say before going to the Phaco chop, that while sculpting, you should not be your Phaco tip or handpiece should not be parallel to the nucleus. You should make sure that you maintain an angulation as it's shown in the top central figure, that your Phaco handpiece should maintain an angulation of 30 to 35 degrees so that you can reach deep inside and there is not much of a pore locking, and you should go along the direction of the incision so that your cornea doesn't get distorted, causing folds, and you'll have difficulty in visualizing what actually you are doing. And second, another important thing is while cracking, you'll have to go deep inside the trench sculpt area, and then do the crack in order to crack the posterior plate of the nucleus. If you are doing it superficially, as is shown in the below on the right slide, then the top portion will be separated, but the portion which is low down, where you need the crack, will not get cracked, and the nuclear fragments will not be separated. So it's very important that the cracking has to be done deep inside the trench. And the third very important thing is, while you hold the nuclear fragments with the Phaco tip, you should hold it slightly on the deeper side of the nucleus, more posteriorly. Otherwise, what actually happens is, if you hold it near the top edge, the posterior sharp edge will bang on the posterior capsule, and many a times it so happens it causes the posterior capsular rupture. And if you get a posterior capsular rupture with the nucleus, the whole almost more than half the nucleus in the back, it's a very difficult situation to handle. So you should be very cautious that you should hold it at either at the center of the side of the nuclear fragment or slightly towards the posterior plate of the nuclear fragment, so that when you try to do the pigmentation, you get the chunks somewhere deep inside and a larger area, and the posterior edge should not bang on the posterior capsule. So now coming to the most commonly used technique, that is the Phaco chop. In the Phaco chop, we do not do any trenching at all. What we do is we hold the nucleus with the Phaco tip and do a chop either with a vertical sharp chopper do a vertical chop or do a horizontal chop with a blunt chopper. So I'll show you another short video which was again taken in 2004 where I'll show you how I'm doing the chopping. As you can see, I'm removing the epinucleus lying in front of the nucleus and then using power to dip the Phaco tip deep inside the nucleus, and then with the help of the chopper I am cracking the nucleus. After having done the first crack, I am again holding almost 90 degrees to the first crack. Then with the help of the blunt chopper I am chopping. Here I am not doing any sculpting, and this is a very preferred technique nowadays because it reduces the amount of power that we use, and it makes the whole surgery very fast. So that's a very good technique, and if the nucleus is not very hard, rock hard, more than grade 4, 5 or 6, then you can employ this technique quite easily, and it's a very effective technique. Now coming to the epinucleus removal. The epinucleus removal technique is again you need to know. Here again, you should not try to catch the epinucleus very deep inside and close to the posterior capsule. The epinucleus should be caught very close to the inside of the anterior capsule and slowly pull to the center, and then till here, till you pull it to the center, you should not apply any Phaco power. Let the fragment come to the center, and then you start using very low Phaco power. It needs a very low settings. As you can see, I'll show you a video of how I do it. I use a setting normally for Phaco. I use 400 to 500 millimeter mercury. For Epinum Plus, I use half 300 fluoride, lower, slightly higher 30, and power as low as nowadays. I don't even use 20%. I use 8% of power with my newer generation machines. Again, a very old slide. As you can see, I'm bringing the whole chunk to the center, pulling it to the center, away from the posterior capsule because the capsule is the anterior depth of the bag is shallow in the periphery, so I'll not do anything at the periphery. I'll do all the activities at the center. That is a very important lesson. You should learn that Phaco activities, Phaco power should be delivered only when the fragment is at the center, because that's the deepest part, and how much ever vacuum and power you use, there is a less chance of injuring the posterior capsule. Now coming to the irrigation aspiration, here again after you have completed the Phaco, what I normally do is inject some viscoelastic and inject it behind the cortex. If you inject behind the cortex, what actually happens is you make a cleavage plane between the cortex and the posterior capsule. At the same time, you have floated the posterior capsule, separated the posterior capsule from the cortex, which makes it easier to remove. Now with a vacuum level of 400 or 500 and a flow rate of 30 to 35 milliliter per second, you can easily remove the cortical material from within the anterior chamber. So you can do it with a coaxial cannula as I'm doing it here. You can even use a bimanual cannula, which is my preferred cannula nowadays, because with bimanual you can reach any points. As you can see that as I'm very close to the posterior capsule, I'm using the spatula between the tip and the posterior capsule so that it doesn't inadvertently catch the posterior capsule. Another very important technique I do in most of my cases is at the end of the procedure, I polish the posterior capsule either with the Phaco tip itself with a setting as low as 10 millimeter mercury vacuum and a flow rate of about say 8 to 10, just to remove all the sets of particle matters which are attached to the posterior capsule, because it's very important for the patient to see very well immediate postoperatively. And sometimes I also try to clean the posterior surface of the anterior capsule so that there is not much of a capsular contraction in the postoperative period. So, to conclude for today, a very good understanding of the fluidics is of utmost importance to do a good phacosurgery. Knowledge and optimization of the machine performance is again very important. You should know your machine, you should know how to control the parameters of the machine. It's like driving a car. If you know how to know your car properly, you can drive it properly. As I've already said, the size of the blade has to be very right so that there is no leakage or there is no heat generation at the incision. Working in a deep anterior chamber is something I actually prefer in all my cases. Wherever there is swelling of the anterior chamber, I inject some viscoelastic, then start again, or increase my bottle height for the more amount of fluid to come in. And vigilance and attention during surgery is something very important. You should go slow, should be very, very meticulous at all steps, and that will ultimately result in extremely safe and efficient fibromyalgia. I'd like to stop here. What I have not discussed in this is the power modulations, the power that we should use during Phaco, which I think once you start doing the Phaco, you should be able to understand it and how to modulate it according to your own surgical technique. Thank you very much. Thank you, everybody.